Hello everyone. We're going to look at more stuff with arithmetic sequences today, and what I really want to look at is how to find the sum of an arithmetic sequence. And so we're going to look at if I want to add all the terms together in a sequence. And remember, arithmetic means there's a common difference. It's going up by the same amount each time, or it could be going down by the same amount each time if the common difference is negative. And so I want to start this by giving you a problem, and to make you feel really good about yourself, I wanted to tell you the backstory of this problem. We're going to try to add all the numbers from 1 to 100. Now the story goes like this. There was this really annoying third grader who was just a pain for his teacher. And so one day, to keep him busy, his teacher just said, you know what, go to your desk and add all the numbers from 1 to 100. And the kid came back in like a minute with an answer, and when she did it all by hand, it was the correct answer. So take a minute, go ahead and pause the video, take a minute, literally 1 minute, see if you can add all the numbers from 1 to 100. All right, so how'd you do? Did you come up with something in the area of 5,000? Because our answer is really close to that. Now to come up with the way he did it, which the reason we're talking about this, what he did is how we're going to get the general formula for how we find the sum of any arithmetic sequence. Now this is arithmetic. Do you notice it's 1, 2, 3, 4, so the common difference is 1. So we're going up by 1 each time. It's an arithmetic sequence. Now the way he did it is this. You just take all these numbers from 1 to 100 and arrange them like this. So let's say, and then plus 99 plus 100. All right, so that's what we want to do, is that. But I'm going to take that same set and I'm going to write it below this, but the other way around. So we'd have 100 here plus 99 here plus 98 here plus, and then when we get down here, plus 2 plus 1. And then we're going to add this together vertically. Now if I do this, you'll notice a pattern of what happens. 100 plus 1, 101. 99 plus 2, 101. 98 plus 3, 101. If you notice, we just get 101 every single time. And if I put all these in here, we have 101 100 times. So that means if I just did 101 times 100, that would tell me the sum of this. Now there's a problem though. Do you notice we have every number here twice? So if I just did 100 times 101, but then divided it by 2, because I added all the numbers from 1 to 100 once, added all the numbers from 1 to 100 again. So when I do this 101 times 100, I'm getting double the correct answer, so divide that by 2. And if you do this, you get the answer for the sum of the numbers from 1 to 100 is 5,050. Now, let's generalize just a little bit. Do you notice 100 is how many terms we were adding together? And 101, this one's a little harder to see. The 101 comes from adding these. Or on the other end, adding these. Do you notice the 100 and the 1 are just the first term and the last term? So, to put this in a little more general terms of what we're doing here, I'm going to call it S sub n. We used A sub n if we were finding a term. We're going to use S sub n if we're finding the sum of the first n terms. So the sum of the first n terms would be number of terms, the 100, and I'm going to put the over 2 with that. And so I'm going to say n over 2, and then to get this number that we multiply that by, we did the first term, which was 1, plus the last term plus 100. So I'm going to say it this way. First term is a sub 1, last term is a sub n. Now in this particular one we just did, n was 100, but this is the general formula for how we could find the sum of the first however many terms of any arithmetic sequence. So this is the big deal for today. This is the thing we're going to be using in order to find sums of arithmetic sequences. So let's try to do this on an example that's different. So this was common difference of 1. This one has common difference of, we go 3, 7, 11, 15. So our common difference here is 4. That's going to come into play in a second. We're trying to find the sum of the first 50 terms. And so I'm going to start to put the stuff in the formula that we know. So the sum of the first 50, so S sub 50, using that right there, equals 50 over 2, because n is 50, we're finding the sum of the first n terms, 50 terms. And so a sub 1, our first term is 3, plus a sub n. Well, n is 50. Now here's where we hit a slight snag. What needs to go right here is the 50th term of this sequence. We don't know the 50th term of this sequence right away. However, this is where what we did the other day comes into play. Do you remember the other day we said to find the nth term of an arithmetic sequence, we do the first term plus the common difference, n minus 1 times. So to find the 50th term of this particular sequence, the first term is 3, plus the common difference, which is 4, times 49. 49 because we're looking for the 50th term, so n is 50, and 50 minus 1 is 49. So let's figure out what that 50th term is here. And so we've got 4 times 49, and then another 3 on top of that. And so when we do that, the 50th term of this is 199. So we want a sub 1 plus a sub 50, the last term of this that we're adding together, which we just found is 199. Now we've got everything that we need. And so I'm going to do 199 plus 3, that's 202, times 25, basically. 50 over 2 is just 25. And that gives me, and this is really funny, by the way, this isn't the answer to every single problem like this. It's just coincidence that this came out to the same thing as this. We'll see in a second, this doesn't work every time. It's not always the same answer. But that would be 5,050. All right, so there's how we find the sum of the first 50 terms of an arithmetic sequence. So if we know the number of terms, we can basically just plug everything in there and figure it out from there. Now, there might be a part of this that you have to kind of figure out. On this one, we didn't know the 50th term, so we had to figure that out using what we knew about arithmetic sequences from the other day. I want to look at one more, because I feel like it's rare that you would come across a situation where you would know the first term and the last term and the common difference and how many terms you're adding together. It's more likely that you would know maybe just the first and last term and have to figure out the common difference and how many terms there are, something like that. And that's what's going on in this example right here. We're trying to find the sum of the even numbers from 6 to 1,248. So, if we're finding the sum of the even numbers, that's basically telling us our common difference here is 2. Because if we're only going even numbers, we go 6, 8, 10, so we're going up by 2 each time. And we have to keep going until we get to 1,248. Now, here's where we got to do a little thinking. Because if I want to find the sum of the first however many terms, don't I need to know what n is? So I need to know what goes right here, because that's going to be the number that's over 2. Now, what I do know on this one is I know my first term is 6, and I know my last term is 1,248. So I've got the first term, I've got the last term. What I don't have is n. And so what I really need to know is, what term of this sequence is 1,248? Let's do a little thinking to figure that out. So what we do know, our first term is 6. Our nth term is 1,248. Now here's what I'm going to do. I'm going to figure out how many numbers are between these two. Now remember, this is an arithmetic sequence. It's going up by the same amount each time, and we even know it's going up by 2 each time. So I'm going to do 1,248 minus 6 to get 1,242. So here's what we have to think. If I need to go up 1,242 numbers, how many terms do I need to go up? And so 1248 minus 6 is 1242. So I'm just going to divide that by 2 to figure out how many terms I have to go up. So 1242 divided by 2 gives me, I should have been able to do that in my head, gives me 621. All right, so we need to go up 621 terms. Now, this is a really common mistake on a problem like this, is you just say, okay, so it's 621. However, it's 622, because 621 terms are how many terms are between the first term and the last term. We're already starting at 1. And so we're starting at 1 and going 621 more terms. And so if that's the case, n in this case is 622. And so then I can plug that in right here, and I can plug that in right here. And now I can figure this out. Because we've got n, we've got the first term, we've got the last term. And so let's figure out what this comes out to. This is going to be a slightly larger number this time, but that's okay. That's why we're using a calculator. And so I get 1254 in here, and then 622 divided by 2 is just 311, so I'm going to multiply that by 311, which gives me 389,994. So there's the sum of the first 622 terms, although at the beginning, we didn't actually know it was 622 terms. But once we figured out n was that, then we've got everything we need to find the sum. And I want to do one more. This last one, the thing that's different, do you notice here, I'm not saying find the sum of the first 50 terms or find the sum of the first 80 terms. It's find the sum of the first n terms. That means we're actually not going to get a numerical answer for this one. We're going to get a formula that still has n in it. And so we want the sum of the first n terms, which means n stays n. We're not going to put in a number for n. So n over 2 plus the first term times the first term plus the last term. So the first term is 6. The last term, well, how do I put in the last term if I don't know where to stop? So here's what we're going to do for the last term, is we're going to put in the formula to get the nth term, which means we need the general formula for the term on this. And so we're going to go back to that formula to find the general term of an arithmetic sequence, which we do the first term plus the common difference, n minus 1 times. First term is 6. Common difference here, we're going up 7, up 7, up 7, so common difference is 7. And then n minus 1 will actually just stay n minus 1. Now I have a feeling there's some of you who could look at that and actually come up with the equation of it without doing all this. And if you can do that, great, go ahead and do that. But I'm going to simplify this just a little bit. And so I get 6 plus 7n minus 7 when I distribute the 7 in there. And then if I do the 6 minus the 7, I'm left with 7n minus 1. So that's the general formula for the nth term. Now, let's just check and see, does that make sense? If I put in 1 in there, 7 times 1 is 7, minus 1 is 6. If I put in 2, 7 times 2 is 14, minus 1 is 13. Do you notice these are just 1 less than every multiple of 7? So it's 7 times whatever term we're on, and then take 1 away. And I know some of you guys are able to just look at them and kind of figure them out like that, and that's awesome if you can do that. And so our a sub n here is going to be 7n minus 1. So there's our first term, there's our nth term, and then all we have to do is some simplifying here. I'd like to make this look a little nicer if we can. And so let's put together what we can here. So we've got the sum of the first n terms is n over 2 times, could rewrite this as 7n, since I have a minus 1 and a plus 6, I could say plus 5. And then from here, you could leave it like this would actually be okay. If these were both even numbers, I'd probably distribute this in and get the squared in there. And so if you really want to, you could do that and say something like 7n squared over 2 plus 5 halves. And that would be fine. Or 2.5 if you really like to write it like that. Or you could call this 3.5 n squared plus 2.5 would be fine as well. All those are equivalent answers. And so there's a formula for the sum of the first however many terms we wanted to add together. And so if we wanted the first 20 terms of this now, if you just put in 20 for n, that's the answer. You want the sum of the first 180 terms, put in 180 for n, there's your answer. And so there's how we find the sum of the first n terms. We don't get a numerical answer because we don't know what term we're ending on, but we do get a formula for it that still has the n in there. So there's the big stuff about how we find the sum of an arithmetic sequence. And so it all boils back down to this formula of the sum of the first n terms is n over 2 times first term plus nth term.